Hey, SICB. My name is Gil, and I study fish. In Hawaii, there are these awesome little fish called gobies. They hatch in the ocean before finding fresh water and swimming upstream as they mature, using modified pelvic fins as a suction disc to climb waterfalls. Ancestral power burst climbing uses a pelvic sucker for attachment and lateral undulation for bursts of vertical propulsion. Derived inching climbing alternates attaching the pelvic sucker and a second oral sucker for sustained bouts of rectilinear climbing. Goby climbing cycle body kinematics have been measured in the past, but here we use geometric morphometrics to measure the change in shape of the pelvic sucker and the attached blood sinus. We predicted that the kinematics would be consistent through the cycle, but differ between methods. To test this, we filmed Lantipes concolor, a power burst climber, and Siciopterus stimsoni, an incher, climbing on plexiglass and ventral view, and isolated images of 10% intervals of each cycle. Using Slicer, we place landmarks associated with the pectoral fins, the pelvic sucker, and the blood sinus, as well as semi-landmarks for the edge of the disc. We ran general Procrustes analyses for each cycle and compared the resulting principal components. We found that the power burst suckers contract upon release and expand upon reattachment, while not experiencing a drastic change in shape. The blood sinus changes shape but remains stationary in relation to the pelvic sucker. The 0 to 60% intervals overlap in morphospace, as movement largely occurs over the last 30% of the cycle. By contrast, the inchers expand and contract laterally with less change in size. The blood sinus moves antero-posteriorly in relation to the pelvic sucker. The 0 to 40% intervals remain similar in morphospace, and the most change happens between the 50 and 90% intervals during the cycle. This study shows that geometric morphometrics can be used to quantify kinematics of flexible structures used in locomotion. Consistent with our prediction, there is a repeatable change in shape across cycles, but those changes are different between methods. Power burst climbers seem to maintain a consistent shape and blood sinus position, but change the size of their pelvic suckers when attaching and detaching. Inchers seem to keep a consistent size, but deform their pelvic suckers and move their blood sinus while they move. We plan to continue this work by looking at smaller intervals within the period of greatest shape change, adding more landmarks to the blood sinus area, and filming juvenile power burst climbers and adult inchers to see differences in shape within the species across ontogeny. We also plan to collect data in 3D to better understand how shape changes during attachment and detachment. Thanks for tuning in, and get in touch if you have any questions. Let's go Team Fish.